In the very first section of this course, we spent quite a while talking about protocols and how it was the rules of protocols that allow us as humans to visually dissect packets, but it's also what allows packet analysis applications like Wireshark to dissect those packets based upon what they expect to see. Now, Wireshark itself includes over 1,000 different protocol dissectors. So one of the things it does when it receives packet data and processes it for you is it tries to detect what protocols it's seen so that it can apply the proper packet dissector to that so you can see the data as it's meant to be seen. This is what allows us to get the useful information we need in the info column in the packet list window, and also to get the appropriate details broken out into individual fields in the packet details window. So this is all made possible by these dissectors, and they all work pretty darn well, but occasionally we run into occasions where maybe they don't, or maybe the wrong dissector is interpreted. And I want to show an example of that here in a minute, but first I wanted to really quickly show the Wireshark website and show how you can actually view those dissectors. Now we're looking at the Wireshark website here. It's a very nice website, and if we go to the develop section here, so if I click on this develop heading, we see there's an option to browse the code. And of course, Wireshark is an open source application, so you can see all the code. You can see everything involved with Wireshark, which is really one of its strengths, is the ability to see what's going on under the hood, and one of the reasons Wireshark has gained such popularity. Now, I can click this, it loads a little slow, so I went ahead and just opened the tab here to the appropriate section, because I wanted to show you that once you open this, there's a folder called EPAN and another folder under that called Dissectors. And when you open this is where you'll find all the different dissectors for different Wireshark protocols. And as I said, there are a whole lot of them. You're going to see some protocols you recognize, but quite honestly, most you probably won't, because there's a lot of edge cases, a lot of protocols you'll never actually encounter for most people in this list. But we see they're all included in all of these various C files that are available here. So you can actually go in and click on these. There's some protocols we can find. So for instance, here's packet-ftp.c, and that's going to be the dissector for the file transfer protocol, which is maybe a little bit more complicated a protocol than some, just because of the way it functions, and we'll certainly get into that when we talk about FTP later. But you can actually get in here and browse the C code and see what's going on. Now, of course, you have to have some ability to read code to be able to do this. These files, you'll see this is commented really well right here, and most of these are commented pretty darn good. So even if you can't write C code, if you have some minimal ability to get through the code and visually inspect what's going on, you should be able to figure out a little bit of what's going on. I mean, after all, we're not doing anything super crazy here. We're just parsing data based upon a set number of rules from the protocol spec. So if you understand, in this case, the FTP protocol spec and what it looks like, you should be able to find the relevant parts of that in the code. So if you have some type of problem or want to extend one of these, you can actually match that up against the protocol spec and kind of understand what's going on. So I definitely wanted to show you where you can browse to that information and how you can find that, because it is pretty useful if you really want to get a little bit under the hood here. So with that said, I want to actually pivot over now to a practical example where we'll show an instance of the wrong protocol dissector being applied. So pivoting over here to Wireshark, I pulled up a file called wrongdissector.pcap, and the file is descriptively named, so it isn't going to be a surprise to you when I tell you that what we're looking at here is a case of Wireshark applying the wrong dissector to a specific set of traffic. And I want you to know what that looks like and how we can fix it, because this is something I think you will probably encounter if you look at enough packets. It is something I encounter from time to time, and this was a really good example of that. Now, in this case, we have just a single conversation going on between 192.168.0.82 and 192.168.0.53. Now, we can look at the info column and see that for the most part, we don't get any useful information. Everything in the protocol column is detected as just plain TCP. So over here, we just get the port information and the TCP flags and so on. Of course, we can see we have a send SYNAC ACK, so we have a new connection being set up. And then we have a lot of push ACKs and things like that. So it looks like we have an individual connection going on right here. Starting around packet 37, we see another request happening. So send SYNAC ACK, so another connection is being set up. So not a lot of packets, only 52 of them, only a couple of conversations going on. But we don't really have a sense of the context or the nature, what the application layer data that exists here might be, if there is any. Now, of course, I can just click and scroll through some of these. So if I start with the first data packet, I'll see something actually quite interesting if I look down at the packet details window. I see FileZilla server version 0933 beta. Now, if you're not familiar with FileZilla, that's actually an FTP server that allows you to transfer files back and forth. Now, if I keep scrolling here, I'll see more related data. I see written by Tim Cossey and his email address. Looks like a URL. Here I actually see a username. I see user admin. Scroll down, it says it looks like password required for user admin, and the pass for user admin is perhaps the worst password you could have when that's your username, and that is admin. We look here, we see logged on. So what we're seeing here, we're clearly seeing that there's FTP communication occurring here, and we're seeing this in the packet details window here. Now of note is notice in the packet, we're seeing that in the packet bytes window. Of note is if we look in the packet details window, we don't see a lot of that. I mean, we see this section for raw data and we see the data listed here in bytes, but we don't see anything broken down. And you should know and you should expect that if you're looking at FTP data, you're actually going to see FTP related fields here. But for some reason, we're not seeing that. We're just seeing this raw TCP data and it's not properly dissected. And I'll show you this because I want you to see what data that's not properly dissected looks like. Clearly, we see this should be FTP data. We see that down here in the bytes when we're converting that to ASCII text. However, in the packet details, we're not seeing that at all, which means something's wrong. And as you might expect as well, in the protocol column, we see everything is marked as TCP and nothing is marked as FTP. So that's a problem. Now, there's a lot of reasons this can occur. Some of them are relatively simple, some are very complex. In this case, this is a pretty simple one. You can see here, if you look at the, let's just look at the first line here, you can see that this is traffic initiated from port 1492 and destined for port 443. Now, if you know anything about FTP, you know it generally uses port 21 as the primary port it uses. 443 is generally reserved for HTTPS or SSL over HTTP, secure HTTP communication. So what we have here is an instance where FTP data is being transmitted over a non-standard port. Now, you might think, well, that's bad, that's malicious. And in some cases it may be. In this case, we don't know the scenario surrounding this capture, so we can't necessarily say that. But we do know that we do have FTP going over a non-standard port, which is probably the reason the wrong dissector was applied here. So if we know what the problem is, do we just have to deal with that? I mean, we're just going to have to not be able to dissect this properly? Well, fortunately, that's not the case. Wireshark actually provides a mechanism that will allow us to apply the proper decoding to this. So to fix that, I'm just going to click here on one of these packets. In this case, I'm just going to click on the one that packet 4, which says the one that transmitted the FileZilla server that kind of tipped us off to what was going on. And I'm going to right-click that. And I'm going to say decode as. So what this is going to allow me to do through the dialog it presents is manually specify some criteria to force a decode onto this file. So force it to decode as a certain protocol. Now we'll see here, it automatically populates some of those values. In this case, it says the field is TCP port and it's 443 and it's currently defaulting to SSL. So it thinks it's SSL traffic because it's over port 443, which is what you would normally expect over that port, HTTPS. Now what I can actually do here is go to current and actually I'll type in FTP, I'll type in F at least, and then click on FTP. And what that's going to do when I apply this is actually force the proper decode to reign supreme, so to speak. So I'm going to click that, and it's automatically going to refresh the file, and notice how immediately I get a lot more useful information in the info column, and I actually now have an FTP header section in this column here, or in this area in the packet details window. So I can expand that and see the properly dissected information. Of course, we can see that other places, such in packet 8. I can see now the username request and being sent when the username is admin. I can see the password of admin being sent, and I can see that the authentication was successful here. So now the packet details window is showing properly the things we saw in the packet bytes window, which is pretty cool. We're able to fix that problem pretty easily. So again, we did that by right-clicking the packet and going to decode as. Of course, doing that here generated a duplicate entry. I can remove that just by hitting the minus button. Now, important things to note here. If I just do this as I did it and then close this file out and then open it back up, that information won't be saved. I'll have to do this again. However, if I click this save button, it's going to save these decodes into my user profile. And it's going to save those so that when I close the file, close Wireshark, open it back up, it's going to be decoded properly as it should be in this case. Now, in this case, the question is, do you always want to decode port 443 as FTP? Well, no, you don't, because most of the time what's going to be in port 443 is actually HTTPS data. But in this case, we just wanted to apply this as kind of a one-off situational thing. So I'm not going to save this because I don't want to accidentally apply the wrong protocol dissector. Make sure you're very conscious of whether you save these or not, because I've seen many people who set up a lot of custom forced decodes, and they'll forget about it and they'll have saved them and they'll open up another capture file and they'll think they just have a bunch of raw TCP or UDP data and it's not parsing correctly because they're applying the wrong dissectors or they're getting something, some type of weird issue going on there. So you have to be aware of that. It's very important, or else you're going to get tricked up a little bit. So very simple. Again, we just right clicked and went to decode as, and we can set these values based upon a number of things. So we chose TCP port here, but I can click plus and add another one of these, and we can do it based upon IP protocol, either type. There's actually a lot of different options here we can use to decide what we want to base our forced decode on. So we pick a field, pick a value, and then pick what we want it to decode to. Again, in this case, I'm just going to remove that and hit OK, and we'll go back to our capture file and see that we have properly decoded FTP data. So that hits the high points I wanted to cover in regards to protocol dissection. Remember, you can always go to the Wireshark website here and go in and browse the code to look at different dissectors. You just go to develop and click browse the code. Pretty straightforward. Of course, if you want to understand and dive in a little more, you can actually look at the developer's guide and learn a little bit more about the standards and conventions used with Wireshark. Overall, you shouldn't have to have a detailed, in-depth knowledge of all the protocol dissectors, even for the common protocols you use. You'll kind of pick that up naturally as you look through the packet details pane and look at how they're being dissected. But I do want you to be aware that the code does exist. You can look at it. I do want you to be aware of forced decodes, and if you ever run into a problem, how you can essentially troubleshoot the application of dissectors to packets. Those are really the most practical things you're going to need to be aware of without actually being, a Wireshark developer or coder who's interested in extending those a little more.